This video is for Comp281 team project. Our team is CloudFront and we have developed a multi-tenant Starbucks ordering portal. It is multi-tenant because it has three store backends. The first store is coded in Python with a Mongo database and it's done by Amrita. The second store is in Node.js with a Mongo backend and it's done by Arpita. And the third store is in Go with a Mongo backend and it's done by Chaya. Now I'll just show you the working of the portal. You can see that it's deployed on Heroku. I am now placing an order. Here you can see three locations. Depending on the location, it is routing towards the store. So the first location is my store 1. You can see that the order has been placed. Now we'll just check in Postman. You can see the order. Okay, now I am checking its status. You can see the order is in placed state. I can update the order. Okay, now we can check in Postman. You can see that the item has been modified. Now I'm cancelling the order. Order has been cancelled. You can check the status. It says that order was not found. You can confirm this in Postman as well. Now I'm paying. Okay, it says payment rejected because the order is already in collected state. I'm placing a fresh order now. Okay, the payment has been accepted. If you check the status, the status is updated using threading. So the statuses can be paid, collected, served, preparing, paid, preparing, served, and collected. Now we'll just see the functioning of the second backend. Selecting the second location, that is the second store. Okay, I've placed an order. This is the API of the second store. You can see the result with the items. You can check for its status. You can update the order. You can check that the order got updated. We can cancel the order. You can pay for the order. Okay, now we can see the working of the third store. I'm selecting the third location, the third store. Okay, it says that the order is placed. You can see that the order has been placed. You can check its status. Similarly, you can update the order. Like I showed you, you can cancel the order and you can pay for the order. Let's just check for the payment. It says the payment has been accepted. Now I'm going to check its status. It says it's in collected status. The status has got changed from paid to prepared to served and collected. Okay, now I'm going to show you our Mongo cluster. So I have created 3 MongoDB instances and I have created a cluster out of it. Okay, here you can see the status of the MongoDB cluster. It says that one of my Mongo instance, it's primary, and the other 2 are the secondary MongoDB instances. All the 3 backends have Mongo cluster.
Hi, so let's take a look at how we are using the Kong API in our application. Uh, we have we send the selected store to the backend, and depending on the store location, we apply the switch to it and decide the URI that we are going to attach to our public IP. So this is the public IP of the instance Kong is running on. It is running on the port 8000. So we have created 3 URIs depending on the 3 backend stores. So we attach the URI to it and we attach the remaining part of the API. This is the post API. Oh, sorry, this is the check API. So we are attaching the order and the order ID to it to see the order status. Using this API, we can get the order status of the placed order. Similarly, we have used the Kong API over here in post order as well as in put and delete. So let's take a look at how we are actually creating one of the Kong APIs. As we can see, we use a curl command with and we hit it with to the port 8000 where Kong stores all of its APIs. We name it Starbucks 3 and we give the upstream URL where the app is originally deployed. We assign it a URI Starbucks 3. So, so Kong actually knows where to route the request depending on which request arrives to it. We enable it with the methods post, head, put, get, and delete. Here we can see here we are attaching one of the plugins that Kong provides. It's a course plugin which so we attach a course plugin to our API. This is the ID of the API that is generated once we hit the command. and we give it the methods get, post, put, and delete, so that we enable cores on all of them. Uh, let's take a look at how we are creating the Cassandra cluster. Uh, okay, 1053 is one of the replication instances, and 1027 and 1012 are one of the main seeds. Let's take a look at how we have configured the Cassandra YAML file. We have given the seeds as 1027 and 1012 in each of the Cassandra settings. It gives us, it basically tells Cassandra that these nodes are the original nodes, whereas the 50 node 53 is actually an extra node. It is a replication node. Let's The only thing that we have to change while creating a Cassandra cluster is the seeds, the listen address, which is the same as the private IP of the instance it is running on, and the RPC address, which is also the same as the instance it is running on. The listen address for 27 and the RPC address for 27. And similarly, we have the listen address for 12 and the RPC address for 12. So when we actually start, we need to start the seed nodes first, and the seed nodes then handshake with each other, and once the Cassandra cluster is up, we can actually use and it's this simple actually to set up a Cassandra cluster.